Hello, Algebra 2 class. I hope you had a good weekend. We are going to start this week. This week is going to be a little different than other weeks. We actually have 4 lessons to learn this week. As a result, we're not going to have a review assignment and we're not going to have a quiz. So there's just 4 lessons. Also, not every lesson is going to have a video. One is going to have a different sort of an activity with it. Or it might have a short video, like with me explaining a little bit, and then the activity that goes with it. They'll all have assignments. Today is pretty straightforward. Just like my normal assignments go, I'm going to lecture and use the even problems as my examples, assign the odd problems. The topic is graphing special functions. So this is more graphing than just y equals mx plus b that we've been doing already. So there's 2 special functions. There's the absolute value function, which we're going to look at, and then there's something called piecewise functions that we'll be looking at today. And for the most part, we are going to be using Desmos, the graphing calculator app, to help us out. So for my little introduction, I'm going to talk a little bit about each one of these, and then the assignment will be split. So it's going to start with absolute value, and you're going to do several of those. And then you scroll down, and then you get to these things called piecewise functions. They're this really funny-looking notation. And finish with that. And of course, the answers are at the end for you to check yourself. So let's talk about graphing absolute value functions. But first, I want to graph y equals x. So this is like a typical straight line, y equals mx plus b. It just so happens that the m is 1 and the b is 0. There's no number there for the b, which makes it 0. There's no number in front of x, which makes it 1. So if we wanted to graph this by hand, the y-intercept would be 0, and the slope would be 1. Now, with a slope of 1, we like to think of slopes as fractions, so that would be 1 over 1. You go up 1 over 1, put a dot, and then just connect the dots, and you get your line. Now, I have not used Desmos very extensively with you guys yet. We are going to be using it more and more as time goes on. So I do want to go over, what if you didn't want to graph y equals x by hand? And I don't like that 1 over 1 there. I'm going to erase it. I just think it looks bad. Anyway, what if you wanted to do this on the calculator instead of by hand? Well, you just type y equals x, and there it is. It's even in red. So you see we get the exact same graph. What's on my graphing calculator screen is the same thing as you see right here. Knowing that, let's graph y equals absolute value of x. Now, I'm going to be using the graphing calculator screen, and down at the bottom is the keyboard. And as I tap it, you will see the buttons being pressed. So I hope this will help you find the buttons when you're doing this assignment on your own. So I'm going to go y equals. So there's my y, and then the equals. And I don't know why it's telling me copy, lookup, share. I'll ignore that. Now, absolute value is over here on the left, right there. Can you see that? Absolute value, then inside of there, I need to put an x. And up on the screen, we have in blue a V shape. The graph of an absolute value, sorry, trying to get the right color here, is a V shape. It comes down like this, hits the origin, and then it goes up like this in that direction. And it kind of makes sense if you think about it. So y equals absolute value x, y equals x. They're the same equation except for those absolute value bars. And what do those bars do if you think about algebra? If you recall, those bars turn everything positive. And if you look at the red line graph here, what's down here is negative, right? Anything below the y-axis is negative. So if you put the absolute value bars around x, it's going to take all those negative numbers and flip them up here and turn them positive. So the V shape of the absolute value graph is really the line shape of a regular straight line that's been flipped upward into the positive region. And that's what makes a V shape. Now, if that makes sense to you, great. If that kind of doesn't work for you, you're confused at what happens, here's the main takeaway. when we're graphing these, we're going to use the Desmos calculator, y equals, and then there's an absolute value button. And then you can type in x, and then you can do other things like +3, -2, even outside, -2 out here. And it'll graph it for you, and then you can transpose that onto paper. So that's absolute value. Next is piecewise. And honestly, no matter what I say about it right now, you probably won't get it until we do the actual examples down below. So I'm just going to talk in general terms here. I'm not going to get specific into an example like I did in that. So in graphing piecewise functions, a piecewise function, it's a function made out of pieces of other functions. There might be 2, 3, 4, 5, 12 pieces. Because this always comes along in October, and I'm clever and funny, I'm sure you think that of me, I call this a Frankenfunction. So just like Frankenstein's monster was made out of pieces of corpses that they dug up in a cemetery, because it's a horror movie, of course, or book. It was a book first. Don't forget that. So yeah, pieces, it's a Frankenfunction. It's pieces of different functions that are sort of stuck together. So the notation, you might have y equals or f of x equals, and then this funny symbol here, which is called a brace. The first piece, a comma, and then a domain statement. And I don't expect you to understand what that means right now, but when we get down to the examples, I'll tell you exactly what it means. Then there's a second piece, a comma, and then another domain statement. And then there can be multiple pieces. In this worksheet, we're just going to do 2-piece and 3-piece piecewise functions. And we are going to use Desmos for the graphing. There is an old school way of graphing these functions by making multiple tables and plotting points on paper and erasing and all sorts of stuff, but we're not doing that. Okay, so let's first do some of these absolute value functions. So imagine I am the student, this is my homework, how am I doing it? The way I do it is how you're going to be expected to do it. So pull up Desmos, you can split the screen like I do, you can split it half and half if you prefer. I actually like this better. And I need to type in y equals, so there's my y equals absolute value of x. Now the x is inside the absolute value bars, and then I have to do -1 outside of the absolute value bars. To get my blinking cursor outside of the absolute value bars, I can do 2 things. I can hit the arrow button, which just moves it over, or I can take my finger and tap the screen. It does the same thing. But here I need to type -1, and that is my graph. So I need to get that graph over here. I am going to ask you to try to be as accurate as possible. If you tap the screen, certain points will stand out, and this can help you get an accurate graph. So here, here, and here. Now that we've got those points, and it's not always 3 points, sometimes it's just 1 or 2, but the more points you can transfer over, the more accurate your graph is. And there it is, and I'm done. Now, can I check my work? Sure. And I try to be consistent in always checking my work. Went too far there. And there it is. But basically, well, I guess it's important to check your work because I suppose you could type it into Desmos wrong. You can't say just because the calculator did it, it's guaranteed to be right, because you could still type it in wrong. So yeah, let's still check our work. Obviously, there's not showing any work. So I'm going to really put a lot of trust in you that you are graphing this and then checking your work. You're not like just copying the answers. All right, let's do number 4. So y equals negative sign first in front of that absolute value bar, followed by the absolute value bar. And then I need to type in x plus 2 inside the absolute value bars, move the cursor over, and type -3 outside. So what do I have here? There's a point -2, -3, looks like a pretty important point, and then there's the y-intercept right there. And if you drag your finger along the graph, it'll give you more coordinates, but when you pick your finger up, they kind of just go away. So only certain key points actually stay on screen when you tap them. So I'm just going to have to do my best to get a picture that looks like that. Now, we will be doing this again in a couple of days. This topic, this absolute value graphing, comes back. So don't just blow this off, or don't, put it in your short-term memory. Try to make sure you're learning and internalizing what we're doing here. Number 4 anyway, I got to check it. And there it is. So it looks exactly the same, except for the color, but that's okay. Number 6, y equals absolute value 2x minus 3. So now that v is a little bit skinnier. 1.50 is, well, that's called the vertex if you care. The y-intercept is 0, 3. You can maybe see a little symmetry over here, that this point is kind of symmetrical with the vertex. Again, if I pick my finger up, it goes away, but that's enough to tell me I put a point there, just for accuracy's sake. And there it is. Scroll down and check number 6. And as you can see now that we're up and going, and I'm not explaining as much, and that looks good. They all did so far. As you can see, anyway, this is starting to go really fast. So it's just typing it in and copying it down. And once you get familiar with Desmos, it goes pretty quick and easy. So this one looks like more complicated than any other. Y equals, there's a 3 first, and then the absolute value bars. X plus 2 inside the bars. Move the cursor over and type in minus 1. And then that is what I need to try to draw on my paper. And if I tap all those buttons, wow, okay, so 0, 5. My vertex is at -2, -1. My x-intercepts, just kind of like here and here-ish. Not super precise when you get decimals, but good enough. Does that look perfect? Nah, but I think it's probably close enough to count as a correct answer. And there it is. Okay, so those are the absolute value equations. I really think you will find them to go fairly quick and easy once you learn how to use the Desmos calculator. And it's good practice to do there. And now, any other graphing assignment we have done, you could have been using this. So if you had like 2/3, y equals 2/3 x minus 4. It'll graph linear equations. You can, still graph them by hand, but Desmos does everything. Okay, so now let's look at the piecewise functions. Number 10. So this is a 2-piece function. There's 1, 2 pieces. If I graph them both at the same time, I get y equals, now this one's interesting. There's a parenthesis, x plus 5, close parenthesis. Then outside the parenthesis, that's to the 3rd power. So I'm going to see the button I'm holding down right there, and then hit a 3, and then that gives me this graph. And it's shaped kind of like a piece of spaghetti. And then if I try to graph the other one, y equals negative absolute value x, it gives me that upside down shape. Now you do not just want to graph these both on the same graph and call it done. That's not exactly how it works. What you may have noticed is I've skipped this little part here, which I had called the domain before. Domain means x values. So what a piecewise function does is it tells you that you're only supposed to use these x values in this piece, and let me change colors. You're only supposed to use these x values in that piece. So you're only getting like half of each graph. How do you do that? Well, you can tell Desmos to do that. What would be convenient and nice is if there's a way to just type this in over here and have it look exactly the same, so it just spits out the graph. Unfortunately, that's one of the limitations of Desmos. It doesn't do piecewise functions like that. Instead, we have to type in both pieces separately, just like I've done, and at the end of each one, we need to enter in the domain restriction. Now, this is where it could potentially get confusing. In every math book and on paper and every test you'll ever see, they put a comma here and a bracket in front. On Desmos, you do not use the comma, you put a bracket there. Now, watch how I get the bracket. Down here is an ABC button, and when you press it, it changes to a different kind of keyboard. Now look at the very bottom row of the keyboard in just about the center. I'm going to hold this button down so it's going to change colors a little bit. That is your bracket. Actually, it's called a brace, not a bracket. Sorry. A bracket's a square thing. This squiggly thing is a brace. But anyway, I hit that button. Now I go back to the regular keyboard, the calculator keyboard, and I just want to type in x is less than or equal to -4. So x less than or equal to, there's the button right there. Oops. -4. And see how that only now shows me a portion of that graph? Let's do the same thing for the second piece of the function in that domain. So I go here, hit the ABC button, that little squiggly bracket, go back to the regular keyboard. Now I need to type x greater than 4. Nope, sorry, that's -4, my bad, -4. So that is the drawing I have to transpose over to paper here. Now, remember before when I said put your finger on the graph and drag it around, you get different points? That might help you, like this point is -4, 1, right here. Oop, let me get back to a pencil. -4, 1 right here. That is right here, that -5, 0. And it kind of curves like this, and then it curves like that. How precise do you have to be here? Not super precise, like is this point really on the graph? Not really. I'm just sort of approximate, and that's okay. But now we have to do the upside down V. Now I want to point out something really, really important here. If you go to the end of this V, there is an open circle. We've seen that before when we've done inequalities on number lines. Sometimes there's open circles, and sometimes there's dots. We covered this in chapter 1. Go back to these domains. This one was greater than or equal to, and this ended in a dot because an or equal to gives you a dot. This one is just a greater than. There is no or equal to. And when we graphed those before, they always end in open circles, and so does this. So where is that point? It's approximately -4, -4, -4, -4. But instead of putting a dot here and drawing the V shape, I don't want to do that. I want to put a circle here and then the V shape. And this is going to be a critical part of your work. You have to get the dots and the circles correct. Let me go down and check number 10, wherever it is. And you see how this is a dot, this is a circle. We've got our sort of spaghetti-shaped squiggle and our V shape. Well, it's an upside-down V shape, whatever you might want to call that. But it's the same graph that's on Desmos, and it's what you should be drawing on your paper. So you will be expected to understand why sometimes a graph ends in a dot and why sometimes it ends in a circle. That's going to recur over and over, going to be very important. All right. Let's do another one. I'll take this one fairly slow again, and then after this we might be able to pick up the pace. Maybe you'll be getting used to the whole process. So, first piece, y equals parenthesis x plus 1, and then outside of the parenthesis I have to hit the power button and make that a third power. Then I accidentally deleted that. Fix that. Move my cursor over, and I go to the brace and type in x is less than 0. Now I'm not going to draw this yet. I'm going to go ahead and type in the second piece. I suppose I could draw it, whatever. Now this is absolute value of x over 2. I'm going to hit the fraction button first. Absolute value of x on top, 2 on bottom. Again, I have to move the cursor over. ABC button gives me that bracket or brace. Man, I should learn how to say that right. X is greater than or equal to 0. So this is what I need to transfer onto my paper here. Let me just trace my finger along and see. This one ends in a circle right here. It sort of curves down and like that. And this one, even though it's an absolute value, it's not a V shape. Why? Well, apparently part of the V has been cut off. So what we see just looks like this. My guess is maybe somewhere else it turned into a V like that, but that's irrelevant. You don't need to draw that in. But do you see how this one ends in a dot? This one ends in a circle. No equal sign, equal sign. All right, let's check number 12. Erase that. Check number 12 and see if it looks right. And yeah, pretty good. Notice the emphasis on the open circle and the dot. All right, let's finish these off now. There's several more because it's good to have practice. Oh, by the way, if it matters to you, this will come up later this week. A function that has a third power on it is called a cubic function. Sometimes we call a third power cube. All right, let's do number 14. So y equals x brace x less than or equal to 2. The second piece, y equals square root. Okay, down here is a square root button. And then I need to type in 2x. Oops, sorry. 2x. Now, do you see how that cursor is underneath the square root bar? If I go to put my brace under there, it's going to mess everything up. You need to move the cursor over. So again, tap the screen or hit the arrow button, and then put in your bracket, x greater than 2. Now that almost looks like two lines. Actually, the red one is slightly curved. So when we draw this, we're going to try to make it fairly accurate. Let's look at this one first. At 2, 2, it ends in a dot. And it is just a straight line sloping down like so. This one does end in a circle, but where that circle is, there's already a dot. So if you circle it, it actually doesn't appear as a circle because the circle is full. And that can happen sometimes. So even though I did draw a circle there, you don't see it. You don't want to draw an overpronounced circle like this. That's just not going to happen. When the open point is filled by another graph, you just let it stay filled. So let me check 14. And there it is. See, they did not put a specific dot or circle here because the dot fills the circle. So there's no need to emphasize anything special about that point. So that's this one. Let's go up to 16. Got 3 more of these to do. Now this one has 3 pieces. Y equals 1 is a constant function. That makes a horizontal line. We've talked about this before. If you have y equals a number, it makes a horizontal line. This business at the bottom that says step and equal sign or inequalities and y, just ignore that. It'll go away. When I do my brace, it just goes away. And then I type in x less than -2. I get a horizontal line that stops with an open circle there. My second piece, y equals x minus 1. Oops. Minus 1. That's a slanted line. Now, when I put in my domain here, I get my brace, I need to do -2 is less than or equal to x is less than or equal to 3. So that creates a line segment. If I trace along, if I touch it and trace, there we go. And then the third piece, y equals parenthesis x minus 3 parenthesis, forgot the 3, raised to the second power. That's called a quadratic, if you really care about terminology right now. And then I hit my brace, x is greater than 3. So there are my 3 pieces to this 3-piece piecewise function. Wow, I'm saying the word piece too much. Okay, so this first line, it's a horizontal line at 1 and it ends in an open circle at -2. So right here is what that piece looks like. This one goes from -2, -3 up to 3, 2, and it is slanted like that. Closed circles on each end, or closed dots on each end, no circles. And then this one at 3, what is that, 3, 3, or 0, 3, sorry. There's an open circle on the x-axis, and then just sort of a curve that goes up like that. So there is my 3-piece piecewise function. Let's check number 16 and make sure I didn't mess anything up. And yeah, looks just like Desmos, except again, Desmos doesn't show you overtly where the circles and dots are. You do have to touch the screen and scroll over. Or you can just learn, if there's no equal sign, it's a circle. If there is an equal sign, it's a dot. Equal sign, dot, no equal sign, circle. I mean, you can learn it two ways. All right, number 18. Right, this is getting, look, if you get this, you want to stop the video and move on, I understand. Well, I'm just going to keep doing more to finish out the lesson. Y equals absolute value of x over 2. Move the cursor over, put in the brace, and type in your domain, x less than or equal to -4. So there's one piece. Second piece, y equals -1. Again, the ABC button, get the brace. We're going to type in -4 less than x less than or equal to 1. And then y equals parenthesis x minus 2 close parenthesis squared. Get my brace for the domain, x greater than 1. So we need a slanted line, a horizontal line, and then a curve that looks kind of like the letter J. Let's see where this goes. Okay, we have a dot at -4, 2. Oop. Blow this up a little bit. And it kind of slopes up here. Yeah, sort of, I think it goes through that point, so it's sort of like an angle like that. Whoa. There we go. This little horizontal line has a circle at -4, -1, which makes sense because there's no equal sign there. And then slide over to 1, 1, 1, -1 with a dot, which again does make sense because there is an equal sign here. And then this little J shape starts with a circle at 1, 1, no equal sign, so that makes sense there's a circle there. It sort of dips down to this point and then curves up through that point, and it just sort of takes off toward the sky. And there it is. Let's check number 18 and make sure that we are good. Yep, exactly right. Good. Number 20, last one. 3 pieces. This one starts off y equals -1. That's a constant function. That's going to be a horizontal line. Brace x less than or equal to -2. So there it is. Ends in a dot because there is an equal sign. Second, y equals an absolute value again. Absolute value of x, and then move the cursor over to go +3. There's our V shape, but that's a complete V. I need to type in the domain, so get my brace on the screen. -2 less than x less than or equal, oop, that 2 didn't pop up, there we go, +2. And now we see just a portion of a V shape. And what is that? A circle there, a dot there. Again, no equal sign, equal sign. And then the third piece is a linear function, y equals mx plus b. Y equals 1x plus 1. Get the brace in there, and my domain is x greater than 2. And this one is a slanted line with a circle. So let's draw this in. First, the green horizontal part, -2, -1 is a dot, and the graph goes like that. The V shape was at about -2, 5 is a circle, 0, 3 is the vertex, 2, 5 is another dot. So my V shape goes like that. And then the slanted line, approximately, exactly at 2, 3, there's a circle, and then it sort of slopes up like so. And check number 20, that's how it should look. And there it is. So It's kind of complicated because there's a lot of new things you're learning as far as how to use the calculator. You're learning a little vocabulary like a piecewise function, a domain, absolute value functions. But you're not calculating anything. You're not solving. You're not working anything out. At this point, you're kind of just learning how to use Desmos to replicate graphs that you could use throughout your studies in math later in this class and in future classes. So I'm going to go ahead and stop here. Contact me if you have any questions. Good luck, and I will talk to you again